My name is Joana Resende. I work at Porto, very close to Vigo. And it's a great honor to be here in such a nice spot like yours. The paper I'm presenting today is called Profit Effects of Consumers' Identity Management, a Dynamic Model. This is joint work with Didier Locel and Govan Long, and it's the first time we are presenting this work, so all your comments and questions are very welcome. And I will start trying to motivate you to the research question we look here. Essentially, in this work, we are going to extend previous work where we looked into firms, the profit effects of firms using information about consumers to profile them and engage in price discrimination. This is a paper that we published in RAND in 2020. And in that model, the consumers are totally passive. So the consumers cannot react to the fact that firms are collecting information about them. And so what we do in this model is to extend that framework to allow consumers to choose at a cost, so this is consumers' endogenous choice, to choose whether they want to reveal their data or not. So this is why identity management, which is the main question of this paper. And so trying to start with motivation, I think nowadays, after we have been living the digital age, we hear talking about digital transition everywhere, so I think nowadays this motivation is not even needed anymore. But just to introduce you to the question, we have been observing that firms are using more and more data about consumers to make personalization strategies. For instance, what you have here is an advertisement of a Netflix series. I actually don't know the series, but I found the image quite interesting because they send different advertisements depending on who you are. So, for example, you see that they can condition on race, on age, and this kind of information. You will receive different image to try to convince you to watch the series. So I don't know if it's good or not, but just to give you an idea. And also, we have been witnessing examples of price discrimination for such a long time. We have all experienced traveling in a plane where pretty much travelers may pay very different prices for exactly the same service. And with the online environment, this has become more and more fine-tuned. So, for example, in Uber, you have an example there. So you have exactly the same route, exactly the same service, and with one consumer gets $16 for a given for a given path, and for exactly the same path, another consumer gets almost $50. And Uber actually assumes that they want to be able to use algorithms to guess what is consumers' willingness to pay and price discriminate accordingly. So they call this Uber route pricing. And if you think about it, this is actually it's first-degree price discrimination, what we have been for a long time saying that this is a theoretical example, we take it just for a benchmark. And it's true that we don't see much of it yet, but this is what firms some firms or the digital giants are thinking of for the future. And you have other ways they can collect data. So, for instance, in the left picture, you have a picture of Starwoods Hotel. I think this is the name of the chain. And what they do is that the key to enter your room is on your phone. So, and as soon as you have that application, they will be able, if you don't manage your identity and privacy settings, they will be able to get data about you, and they will be able to possibly using it for price discrimination, not necessarily because they want to hurt the consumers and charge more price, but they can say, we will use this information to personalize the service. So it's not clear whether this will be welfare detrimental or welfare improving, but this may open the door to it, because if they are in your phone, they know where you are, they know your habits, or that there is the potential for that. And so, indeed, I take this quotation, which I find quite impressive, because a tech reporter from the New York Times reports that she was, I'm going to read it. In the fall, I took the right of access for a test drive, asking companies in the business of profiling and scoring consumers for files on me. One of these companies, Sift, which assesses a user's trustworthiness, sent me a 400-page file that contained years' worth of my Airbnb message, Yelp orders, and Coinbase activity. So this, can you imagine 400 pages about your searches online? So the information that they can potentially collect is really, really huge. And I mean, as I was saying before, I'm not saying this, for me as a citizen, I find this quite scary, but it's still, it may also be used, or they argue that can be used to improve the service they give, and so on and so forth. So there is an open question whether this will be good for consumers or not. And if you focus only on profits and prices, which is actually the focus of the present paper, we will not introduce consumers this utility for knowing that someone knows what you are doing. We don't have this kind of thing. But even if you look only at prices, it is not clear what are the effects, because on the one hand, if you have competition, it may be the case that firms, since they know your willingness to pay, they might compete very fiercely for you because they know who you are, and this may be actually good for consumers. And in static models, static competitive models, this is often the case, that the fact that firms do customer recognition in static models usually is bad for profits and good for consumers if you only consider prices and you do not account for this utility that, you know, people are controlling your life and these kind of things. And as you know, there have been a lot of discussions on privacy concerns. In Europe, since 2016, we had the GDPR in charge. A lot of political discussions on the need to protect consumers and how you do it. And so, especially tech-savvy consumers are trying to find ways, if firms can hurt them by using this information to charge higher prices, to circumvent this possibility. I don't know, probably, at least I already did it when I am trying to buy something online and I see that there is this discount for new registrations. I create a new email account and then I go and get my discount. So you evaluate the gain that you will get from what you are buying and what the time, at least, that you have to spend to create this new email, and so on and so forth. And so you make this choice. So this is more or less the picture that you have with this guy that is on his phone trying to buy, but trying to hide who he is or she is in order to get better offers. And there has also been put by Susan Athey this idea of privacy paradox, that at the one hand, consumers are very worried that firms use the information about them, but on the other hand, when you look at consumers' behavior online, they have they don't seem to care. They don't care much on this. So this is a paradox. Everyone would agree that it's a concern that people are collecting files with 400 pages about you. But then when you are, consuming something online, when you are choosing what series you want to watch on Netflix, or when you are choosing at what time of the day you want to charge your car, and so on and so forth, you don't think that this data may be used to change firm strategies afterwards. And as I was saying, there is an increasing political concern, and you have in Europe GDPR, and also in the US, you have several discussions around these issues, with some states more engaged into introducing legislation, others not so much. But there is a public discussion. What should be the role of public policy and how can we assure that we are protecting the interests of the consumers? So this paper, what we try to do is to present here a very simple model. This is a very stylized model where we will try to bring the dynamic element. So I was saying that when you look into static models, most of the times price discrimination based on customer recognition is actually well for improving for consumers and profit detrimental. We try to bring here the dynamic element and see how this goes if you have a dynamic setting. And because we are introducing this new element, we simplify the market structure and we look at a monopoly model. This is a non-durable monopoly with customer recognition, price discrimination, and on that respect is pretty much the same setting that we published in the Rand paper. And the novelty is in the fact that in consumers, we give consumers the option to choose whether they want to remain anonymous or they prefer to reveal information about themselves. The model will be very stylized. We will look into two customer profiling regimes, just like in the other paper. So we have a theoretical benchmark that is the full information acquisition. In the full information acquisition, when you buy the good, you immediately, if you don't choose to remain anonymous, the firm immediately knows what is your willingness to pay, and she will charge a price equal to your willingness to pay. So it's first degree price discrimination, like in the textbook standard example. And then we look into a more realistic example that is called purchase history information, just in the other paper. In this case, the firm cannot obtain information on what is your exact willingness to pay for the good. But what the firm does is she knows that consumers with higher willingness to pay are the first ones to buy the good. So she will group consumers who buy the good in the same time in the same cohort. So it's like she segments the market in vintages, in cohorts, and practices third-degree price discrimination over these cohorts. So it's like you will receive a different price depending on the moment of your purchase. And so, essentially, as I was explaining, these two profiling regimes will lead to two different assumptions regarding price discrimination. First-degree price discrimination over all the returning passive customers in the FIA case, and a third-degree price discrimination in the other case. And as I was saying, this is a simple extension of the other model where we give the possibility to conceal their identity. And although this is a rather simple change, results will be quite different, or they may be quite different. So essentially we will look into these questions: how endogenous identity management will affect optimal market expansion. And this is why having a dynamic model also brings news here, because we will be able to describe the market expansion. What are the profit effects of variation in the customer's privacy cost? Because this is where we try to give a policy recommendation, in the sense that we look, essentially, as you may guess, because consumers will have to bear a privacy cost, their decision whether to hide or not their identity will depend on this privacy cost versus their willingness to pay for the good. And so, if this privacy cost changes, how will be the profit effects? Most of the people, when we were having discussions on this theme, they tend to think that if privacy costs are lower, then profits will be hurt. So firms will be hurt by regulation, by tighter data protection regulations like the GDPR. And we find here in this paper that this is not necessarily the case. And I would say this is the main message, is that we find a non-monotonic effect of changes in the privacy costs. So in some specific case, firms may benefit from tighter privacy regulation. And I will explain you the intuition why it's very straightforward. And so we also finally look at how equilibrium outcomes are affected by the firm's profiling regime. This is also something that we look at. So the paper is related to several streams of literature. Of course, there will be reminiscence of the dynamic monopoly pricing problems, like in the Coase conjecture. It's also related to the behavior-based price discrimination and personalized pricing literature. Most of these works, as I was referring, are the ones that look into this from a static perspective, concluding that firms are hurt by customer recognition, and also it relates to papers on customer identity management. So the closest paper to ours is Konitzer, Taylor, and Wagman, where they also look at consumers' identity choice in an endogenous setting, but they only have 2 periods. So, for instance, they cannot describe market expansion and so on and so forth. I should also mention as important works, this is static paper, Shoeking and Matsushima, recently published in Management Science, where they find that consumers, firms actually benefit from consumers' identity management, because in their setting, firms are able to personalize prices to returning consumers. And when they personalize prices, you will have sort of, it's a competitive setting, so you will have sort of Bertrand competition. And the fact that some consumers hide their identity will allow firms not to be in such tight competition. So this is good for the firms. You have Acquisitive and Varian, Belflam and Vergotti. This is a monopoly static model, or Casadesus, Mazanel, and Hervas Drena, where they have a competition model, but also look into a static monopoly setting as a benchmark. I will try to give you an overview of the ingredients of the model. As I said, this is the first time I'm presenting, so I'm not sure whether I put too much information or too little information. So if there is something that is not clear, please interrupt. We have a monopolist. This monopolist produces a non-durable good at a constant marginal cost. We normalize the production cost to 0. We have a continuous time game, but we assume that, like pretty much in the Coasian fashion, we assume that the firm can partition time into a sequence of contracting periods. We will call these contracting periods that they have a duration delta. So this is the commitment period for those who are familiar with Coasian literature. We assume there is a continuum of consumers that live forever, and the consumers are represented by their type, theta, and the type theta gives the consumer's willingness to pay for the good, essentially, which we assume to be uniformly distributed in 0, 1. So everything is pretty simple. Each consumer of type theta will buy at most 1 unit of the good at each instant of time, and she gets an instantaneous utility of theta minus p. So super simple. We have a discount rate of R, that is so that the dollar paid at the end of the contracting period is only worth beta, that is the exponential to minus R times the commitment period. So we can assume without loss of generality that R is equal to 1. More ingredients. So I don't know if there is any question on this. Okay, good.
One question is that we use P in each customer of type theta buys, and the net utility is theta minus P. P is the what?
P is the price, but I will explain you better this later, because you will have several prices. You will have several different groups of consumers, and you will have several prices. So in particular, we will have to consider an introductory price that the firm is targeting to the consumers who are buying the good for the first time, and before the consumer buys the good, the firm knows nothing about the consumer. Once the consumer buys the good, the firm either learns theta, if you are in the full information acquisition scenario, and then she charges theta because she can use these technologies to charge different prices, or you are in the purchase history information scenario, and in that case, the firm will charge a price that is similar to consumers in the same cohort, but you will have different cohorts of consumers, so you will have different prices. I will try to explain better this later. So for now, I'm calling it P, but there will be many Ps. So thanks for the question. So as I was saying, the firm collects data on the tastes of former customers. So consumers need to buy the good at least once for the firm to get some information. And then, if the consumers do not choose to remain anonymous, the firm gets some information on them. Which information will depend on the profiling regime. So old customers, they may conceal their identity, incurring in an upfront cost, that is denoted by C. Okay? This is the simplest case you may imagine. The simplest case you may imagine. So, and this is an assumption actually. You, at the beginning of the game, you have to pay, or when you choose to remain anonymous, you have to pay this cost, and then you are anonymous forever. We have studied a bit what happens if this is not the case. So if you have to take the decision every period and the cost is the same, and the results will remain unchanged, provided the fact that you have to bear the cost every period do not change your decision of when to start hiding. If this doesn't change, results remain valid. If this changes, then the model becomes much more complicated. Yes?
In repeated occasions, to hide is costly.
Yes, so this is an assumption that we have. You decide at the first time, so we try to argue. The argument we try to present is that this is, you can imagine this as the cost to read the policy, privacy policy of the firm. You know, if you want to read, you have to stay for some time and read it. They have done experiments regarding these terms of acceptance that we sign. And for instance, I think this was in the US, but they did this experiment where they put in the middle of all those small letters that you agree on giving away your kids at some point, and people would immediately say yes to all because they don't spend time. So if you want to spend time reading all the things, this is one thing you do once, and then you don't have to repeat if the firm does not change. This is the kind of example we try to argue, but it's an assumption. So it's... So, if you choose to pay this upfront cost, then you will remain anonymous, and every time you are buying the good, the firm will have to take you as a new customer. So you will always be buying at the introductory price. And if you are familiar with cost conjecture models, you already know that introductory prices will go down with time, so you will be gaining of buying the good at the lower and lower prices. So this is the incentive for you to hide the identity. This is a model where all the effects come through price. I don't say that this utility of having people knowing about you is important. This is super important, but it's not in this model. The passive consumers, they don't pay the cost, they choose not to pay, but then the firm will profile them. And so instead of buying the good at the introductory price, and we will call the introductory price this P to the power with the upper script I, they will get a target price, and actually there is a typo there. I don't know if I can write, but here it should be P of I, theta n. So because the price will depend on your theta. The price will depend on your theta. And this pi theta n will be equal to theta if you are in the full information acquisition, because they know you are, they charge your willingness to pay. So if you are in this scenario, you know that the only period, as a consumer, you know that the only period where you will get utilities when you buy the good for the first time. Then it's always zero unless you hide your identity. And you can already imagine that consumers' incentives to be actively managing their identity will be much higher in the full information acquisition than in the other scenario, because it will allow you to bypass first degree price discrimination. If you are in the purchase information acquisition scenario, we will show that this price that each vintage will get will actually be equal to the willingness to pay of the last consumer buying the good. So the firm essentially know that all the consumers in that cohort have willingness to pay higher than, we will see it's theta n plus 1 in period n, and so she charges exactly the willingness to pay of the lowest consumer. So there will be only one consumer that will not get surplus every period, that is the marginal consumer. I will give more information on that. For now, we shall also assume, and this is something we will prove later, that the anonymity decisions are made in the initial period. And they can be translated into a cutoff strategy, which is quite intuitive. That is, we will be, when we are looking at consumers' decisions, whether to become anonymous or not, we will be able to find a theta tilde, that is sort of an indifferent consumer to become anonymous or not, with this theta tilde being, with types higher than this theta tilde choosing to hide, and it makes sense because those are the guys that have high willingness to pay. They don't want to reveal this information to the firm because then the firm will charge higher prices. And the reverse thing for lower types. They have a low type. They don't mind that firm knows their type because the firm knows they are not willing to pay a lot, so they don't care that the firm knows this information. So it's quite intuitive. And it's important at this point to note that the monopolist will actually, in every period then, deal with three groups of consumers. He will have the active consumers, those are the highest types. They have types higher than theta tilde. Those are untraceable, and they will be treated as new ones. The firm cannot separate them from the last group, that is the new passive consumers, that are the ones that are buying the good for the first time in period N. So the active consumers, they are hiding their identity and they buy the good in period N. The new passive consumers, their willingness to pay is low, so the price was not sufficiently attractive before, they are only buying in this period. So the firm has a problem here in the sense that if she wants to continue expanding the market, she will have to reduce the price in order to attract more new consumers. However, by doing so, she knows that she will lose markup in the active consumers who are there, but hiding their identity. And this is why the results will be different from the Rand paper, because in the Rand paper we get that the market is fully covered. Here, because you have some active consumers, the firm will not want to cover the market, because if she do so, she will have to lose markup on these high thetas that are hiding the identity. And on the top of this, you still have the old passive consumers that are the ones whose preferences are known by the firm, and so the firm will want to engage in price discrimination, first degree in the case of full information, third degree in the case of purchase history information. Yes, please.
Yeah, just a quick question. I know this is an assumption, right? And this is an Astelizer model, but I don't know how you can be active forever. I mean, when you make a purchase, this firm already keeps your address, keeps your identity, and keeps your credit card. Second time around, when you enter and you want to hide your identity, you can do so. But in order to perform like the final purchase, you have to reveal again your credit card, for instance. So I don't know whether in the long term, even when a person wants to remain an active hider, he or she can do it in reality due to the technology advantages in place.
Yes, so yes, I understand your question, of course. So you would have to imagine a situation where the firm is forbidden to store information about you. So after the first purchase, she will not record any information about you. So you will not consent in the privacy settings to keep your address, who you are, none of that. But
that's a good point. Yes.
yeah, but yeah.
You could make it implicit in the paper if.
Yeah. Yeah. This is, I agree, is an assumption that we have. So I don't know if we will be able, because we try to do this with firms that taking this decision every period, and either you have a situation where your cost is the same but discounted for every period, and if this is enough to guarantee that the firm the consumers choose to become anonymous from the start and always become anonymous, even if paying the privacy cost every period, things will remain exactly the same. because the cost is simple cost divided by the interest rate. But it may not be the case, because then you have to look into more different kinds of interaction, because the fact that they may hide today and not tomorrow may change firms' prices in order for this to be an equilibrium. So we were not able so far to describe the problem technically. So yeah. So this will be a world where GDPR is really enforced so that you are sure that the firm cannot record any of you, but we know this is not the way to go. Yes, so now what we do is to, I don't know if I will have time to go into all the details, but I will try to explain, because this is, if you understand this, then the rest is more algebra, let's say. So what we do next in the paper is to try to study the behavior of each type of consumer. So if you look, for instance, at passive returning consumers, so passive returning, I'm talking to this group of individuals whose preferences are to some extent known by the firm. So if you are, in the case of full information acquisition, these consumers will be charged with theta, so you have this price equal to theta, as I was saying before, and the firm in period N will make a profit equal to, if you call theta in the lowest type who is buying the good for the first time in period N, the firm will essentially make and theta upper bar is the theta with the maximal buying the good. You essentially have the integral of theta, because this is the price it is charging to all consumers and the cost is equal to 0, and you just have to discount because the duration of the, remind that we are looking, this is instantaneous. This is the instantaneous utility, theta minus p, but we are looking this into period N. There is a duration of delta with beta equal to this. So this is the profit during period N, let's say, in the case of full information acquisition. If we are looking into purchase information acquisition, then we have to understand what is the price for each vintage, and the firm profit will be the discounted again for each vintage. So we have to look into profit in period N for vintage I, for example. The profit of vintage I will be theta I minus either theta I plus 1, that is the last consumer buying the good in the preceding period, or the price if the price leaves some consumers in the cohort out of the market. We show this is not the case, so we show that the optimal price to charge in each cohort, as I was saying before, will actually be theta I plus 1, and so the profit, the optimal profit in period N over all cohorts of customers, then we have to have over different cohorts of customers, will be given by this expression. So this is a bit technical, I will go fast, but if you have questions, maybe at the end I can clarify. New passive consumers, they haven't bought the good before, they will face an introductory price because the firms do not know who they are, and here it will depend if the introductory price is actually above the willingness to pay of the last consumer to enter the market, then no more consumers will enter, because the introductory price is too high for these lower types who didn't find attractive to buy before, they will not still find attractive now. If this is not the case, so if the price is below this theta n, we will have a new cohort between theta n plus 1 and theta n. This is the new consumers who enter the market. And they will buy because the willingness to pay of the lowest consumer in this cohort is higher than the price. And so we will call this theta n plus 1 will be the last consumer to buy. We will call this the marginal passive customer in period N. So theta n plus 1 is the last consumer buying the good in period N. The last in the sense that is the one with the lowest willingness to pay for the good. And this pricing policy essentially means that she is serving, because the old customer already found attractive to buy the good at some point, it makes sense that we get this price. Because if she found attractive to buy the good at introductory price, when you can price discriminate, you will have to find an attractive solution for you, so you will not leave old customers out of the market. Essentially, this is what this price policy implies. And so, when we look into this, the utility of this old customer when she's buying the good, you will have that this utility will essentially be 1 minus beta, theta n plus 1, that is his willingness to pay, minus the introductory price. And this is the same in both profiling regimes. Because, why? Because this consumer is the one that, even in the purchase information acquisition, he will not be able to get future surplus because he will pay a price equal to his willingness to pay. If you are not looking into this marginal consumer, this utility will be different in the full information or in the purchase information. Why? Because in the full information, no matter what is your type, the firm knows you are, you will have zero surplus. So this remains unchanged. But if you are in the purchase information history scenario, the consumers who have higher thetas than theta n plus 1 and are in the same vintage will get surplus, will get an information rent. And so they will be able to get higher utilities. The monopolist profit over new passive customers in period N will then be equal to this expression. So this is the size of the cohort that the monopolist is serving. And the notation may be a bit confusing because theta n is the passive customer in period N minus 1. And this theta n is above theta n plus 1 because in the subsequent period you are serving lower types. Every time you are growing to lower types. So this is the size of the market. This is the price you are getting, and we know the price can be written like this, so we can write the profit like this, and this will be useful for us later to compute the Markov Perfect Equilibrium. Really bad on time. For the active consumers, all active consumers will choose to buy the good in period N, of course, because if the good is sufficiently attractive for new passive consumers, it should be attractive for active consumers as well. And this is the profit that they will make. Essentially, you will have that this theta must be higher than the price, again, because if you have new passive consumers buying the good, this willingness to pay, and remember, these are the ones who are choosing to become active or not, it should be high enough for you to buy the good, and so you can write the profit. So essentially all this talk, it's a bit mathy, but it's to see the way we are computing the profits the firm is making in each group of consumers, because we will have to use this expression of profits to compute the profit that the firm makes in every period, and then use this piece of information to build a Bellman function for the dynamic period. And so here we go on for the decision to be active or not. We are looking into the participation constraints. So in order to avoid making this very mathematical, I will skip a bit this part. The main difference here, you see that if you are under full information acquisition, and if you are looking at the utility of the marginal consumer, essentially the participation constraint says that the utility of buying today is equal to beta times the utility of buying tomorrow and your information rent. And in this case, you will get information rent only for one period. And what is the information rent that you are getting is the fact that you will be in this vintage with lower price than in the vintage if you have bought before. If you are in the full information, in the purchase history information, is more or less the same, except you get this rent every period. So you don't have this discount because you are having this as every period. And so we can then, using indifference condition, to compute this theta tilde endogenously. Okay? Then we look into so these are sort of the primitives of the model that will then allow us to compute the Markov Perfect Equilibrium of our model. And to this end, we define as the state variable of our period the smallest willingness to pay of all previous passive consumers. So essentially, if we are in period N, this is theta n. Theta n is the marginal customer in period N minus 1. And what we do is to essentially, you have a game between the monopolist and the consumers. where the monopolist has to choose the expansion rule. What is the size of the market I want to grow every period? And the consumers have to guess their future utility, so they will have to formulate expectations, and they need to choose optimally when to become active or not. And so we can, in this Markov Perfect Equilibrium, consumers will have a Markovian expectation rule. So this is to say that the expectations they formulate as a function of theta will be equal to the real utility they have. So this is rational expectations model. The firm's Markovian strategy will be a cutoff rule that is saying how the market will grow as a function of the previous state. So essentially you are choosing what is the next state given the current state. And yes, and it will be decreasing, right? You will be serving more and more customers. And formally, a Markov Perfect Equilibrium will be a set of Markovian cutoff rule, a Markovian expectations rule, and a threshold representing decision to become active or not, such that the firm's policy is the best reply to consumers' behavior, so both the expectation rule and the privacy threshold. The consumer's expectations will be rational given the firm's strategy and also their anonymity decisions, and the privacy decisions will be correctly taken given the anticipation of the Markovian strategies. We solve this. The way we find to solve this is a two-step method, let's say. So first, we will find the Markovian expectation rule and the Markovian cutoff rule for a given theta tilde, and then we will uncover the optimal theta tilde. And for the sake of simplification, because our model has a quasi-linear structure, we will look for quasi-linear cutoff rules in the case of firms and quasi-linear expectation rules in the case of consumers. So what we do, and I will not spend any time on this, is to obtain these parameters as a function of theta tilde in the first stage. So how do we get the Bellman? What I was trying to explain before is that you will be able to compute the profit that the firm is making in period N as the sum of the profit made on former passive consumers, made on new passive customers, and made on new active customers in period N. And then we can write the Bellman equation, that is simply the sum of these profits plus the beta times the value function evaluated in the next stage. And then, you know, this is maths that we do under this, so we can obtain an equilibrium with this linear structure I was referring before, and I will now spend some time with the results. So what we find? We find in the case, and we separate results for full information acquisition and then for purchase information acquisition. So with full information acquisition, we were able to determine a threshold on the privacy cost, this is C upper bar FIA, where we find that the Markov Perfect Equilibrium with endogenous identity management is such that if the privacy cost is below this threshold, there will be some active consumers. So if privacy cost is low enough, some consumers will choose to be active. It makes a lot of sense, because if it's too expensive to be active, no one will choose to protect, it's simply too expensive. What we do here is to quantify what too expensive means. It means being higher than this threshold. It is also the case that if and this is different from the Rand paper, as I was saying before, if C is low, then some consumers will be left unserved. If C is high, then all consumers are passive and the market is fully covered. And of course, as expected, the fraction of unserved consumers as well as the fraction of active consumers decrease with the privacy cost. And so we will find a limit in the theta where the market doesn't grow anymore, the market expansion is incomplete, provided that the privacy cost is not too large. And when you look into, yes?
One quick question. You are always assuming that the privacy cost is negative. That means, it's always positive, meaning
Yes.
it does not go to the negative side.
Yes.
I'm just saying that because some people think that to give away your data is also very good for you, as you indicated before. So
Yes.
maybe the cost of privacy is not always negative. I know many people who give every information they have in order, for example, when they do the login in Netflix, they have the better feed for their preferences. The same with many books when they buy it online, and clothes and so on and so forth. I'm just saying that.
Yes, I haven't think about I always tend to think it's very bad.
Yeah.
But you have a point, yes. This is, we are assuming it's negative, yes. It's positive, sorry, non-negative, yes. But it's perhaps worth looking at that situation, yes. Yes. What we do next is we look at what is the effect on the aggregate discounted profit, so for the overall period as a function of this C. And you see this in this picture, there is a non-monotonic function. So it first goes down and then it increases. So if you think at the polar cases of C equal to 0 and C equal to this threshold I was showing you before, the threshold will depend, they are globally increasing, which makes sense because for a monopolist who can engage in price discrimination, if you can do that, it's the best for you. But there is, if you start with a sufficiently small cost, in the neighborhood of this cost, firms actually benefit from tighter policy regulation. And what is the intuition for this result? The intuition for this result is related to the dynamic nature of this there's someone who is really trying to reach. The intuition for this problem is that when you have a variation in C, the direct effect is C goes down, more consumers become active. This is bad for profits because I will not be able to engage in first degree price discrimination. Direct detrimental effect to profits. But when C goes down, because there are these active consumers, I will not have so much incentives to reduce my introductory price because I am afraid, I know that this I'm losing markup on consumers with higher types who are masquerading as new consumers. So this means I will left more consumers unserved, but I will be charging higher prices due to this strategic effect. And so they go in opposite directions. And what this is showing us is that if we start with small enough C, so if you start, let's say you have beta equals 0.9, if you start here and you reduce further C, the strategic effect will dominate, and so this means that firms will take advantage of the higher introductory prices they are now charging and get higher profits. So this is somehow counterintuitive of what you would expect. Then we do the analysis for the full information, for the purchase history information. Qualitatively, results are exactly the same. In this case, we don't obtain, for the quasi-linear equilibrium we were providing, we don't obtain that the Markov Perfect Equilibrium always exists. So we have an upper threshold on beta, because we need to, this restriction is coming from the fact that for the problem to be stable, you need, where is it? This coefficient needs to be between 0 and 1, and this will lead to that restriction on beta. And actually, it's also not the case that with purchase history information that consumers are always better off concealing the identity at the very beginning. So this will introduce another restriction on beta, but qualitatively you have the same results. So I will not insist on that. And you also obtain, as before, that profits are non-monotonic functions of the privacy cost. But now, differently from before, so before, if you remember the profits, and if you compare the two limit cases of C, the profits would be increasing. here they are decreasing. And another interesting result is that if you compare these figures over here to the one with full information acquisition, you get that profits are always higher with full information acquisition, but the difference will be much higher in this case. So here you have, for instance, a profit of 0.4, here is near 0.25, whereas here you have profits also near 0.25 for small values of C, but below 0.25 for higher values of C. So if you have a very large privacy cost, firms, we don't have this in the model, but if you endogenize firms' decision to invest in more accurate profiling technologies, they are expected, we conjecture, they will do more so with a high privacy cost. And this is the limit I was referring before, for us to be sure that the assumption they do it in the beginning of the game holds. And so we are reaching our time limit, so I will sum up the managerial implications. We find that independently of the accuracy of the profiling tools, when C is small, managers should target higher introductory prices to the segment of new consumers. So market expansion will become slower when the privacy costs are low. Full market coverage will never be reached, and we have these interesting results that profits are U-shaped functions of C. The magnitude of these effects will depend on the firm's profiling capabilities, so the measure of passive consumers who are served as expected will be graded under purchase information acquisition than under full information acquisition. This is to be expected. Why? Because under full information acquisition, if you are passive, you are going to be charged your willingness to pay. Then you don't want so much to be passive. In the other case, as long as you are not the marginal customer, you may get some rent. And so more consumers will be active. And therefore, and we also find that under coarser customer profiling tools, the equilibrium value of the slope of the firm's expansion optimal rule will be greater than under full information, which means that market expansion will be faster under full information, which also makes sense because you want to know as fast as possible what are the preferences of your consumers. So the main conclusions are that the profit effects of changes in identity management costs may be ambiguous, so firms may actually benefit from government regulation to tighten privacy protection, as long as we start with a low C. And also the profiling regimes are also relevant, so profits are, as we have seen, globally increasing on C and the full information acquisition, but globally decreasing on C and the purchase information acquisition. And this profit differential is much lower for low C, so tighter regulation may hinder firms' incentives to invest in accurate profiling. And of course, this is just a stylized model. Many research avenues are worth. First, for sure, we need to study deeper the policy implications of customer privacy protection rules. This question that was raised here, that if consumers have to repeat or not the upfront cost, this is a very relevant policy question that perhaps is worth looking at. In perhaps a bit simplified setup to at least get some intuition. Firms' endogenous investment in customer profiling accuracy that we don't have endogenized in the model, and the competitive profit effects of consumers' identity management. We have a monopoly model, and we know that if we have competition, results may be very different. So thanks a lot for your attention. I hope.
Joana, ¿cuál es tu impresión entonces? Once have done this work, what is your impression regarding how we, the customers, should act with our information? This is the conclusion of your work regarding this question.
If you have a high willingness to pay for the good, for sure, it is good that you hide your identity, because you will have better price offers. So If you only look into, and if you care also about protection, then even more you should protect yourself. But there is also a group of consumers who is hurt by this situation. There is the lowest types, because the lowest types, they don't value the good highly enough to protect themselves, but they will never be able to buy the good because of the existence of these active consumers with high willingness to pay that will make the firm pay. And if you associate this, for instance, your willingness to pay also with matter of related to your income, from a policy perspective, you may not have a high willingness to pay because you know you cannot afford, for example. This means that this group of vulnerable consumers should deserve special attention from the policy makers, which is a debate I don't see much on the news. So the fact that you can protect yourself, that is your choice. One important point I didn't mention is that the only fact that you can protect, even if you choose not to do it, but that you can, is important, because if you look into, this is even more evident here, if you look into the case of C equal to 0, that in principle, of C very high, that in principle no one will choose to protect, the fact that you can protect will avoid that the firm is getting 0.25 is the profit that the firm makes with exogenous consumers, the repetition of the static gain, because you have the static profit, you have a distribution between 0 and 1. If you do standard monopoly on this, you get profit equal to 1/4, 0.25. And the simple fact that you can protect, even if no one is protecting, will make profit below this, so it's good for consumers that at least you have the possibility to choose to protect. And then each consumer will have to choose, depending on the willingness to pay and the privacy cost. If you are in a full information acquisition, for sure it will be better to protect.
In any case, just very quickly to conclude, I like a lot your work. I'm not a theory person, as you may know, I tell you directly. And I've been thinking a lot about the presentation and the implications and all that. And how do you also write the net utility function, right? Like theta minus p for the general terms. And in my case, I will, not knowing theory, attention, which is an important aspect, and sorry for being so open maybe about this, or being so, I don't know, is I will write it like theta plus sigma minus p, where sigma is the utility you give to your privacy, in the sense that sigma may be positive or not necessarily positive. This is how I see the problem. And looking at teenagers, they don't care about identity at all. I don't know whether this is a generational issue or not, but the truth is that they really don't care a thing about identity and privacy. Or privacy, as we understand it. They have a lot of identity and they think that claiming out identity is just showing off everything they have and giving away privacy. So just a thought. I mean, this is how other people may see the problem as well, as you presented. But I like it a lot, super a lot. I like your work very much. Another issue that I think about is the cost of remaining private. For me, it's increasing over time, right? Mm-hmm. And I try to do it a lot myself, also as probably you do. But it's really difficult because you have to register every single time.
Yes.
Point one. Point two, if they see a credit card related to a previous purchase, then they are starting to ask you, do you want me to use the same delivery address? Do you want to do another different address? And so on and so forth. So,
and they control as well for the IP, for example. Yes. At some point I was registering new email, but if you do it in your home, they will
so
not.
So basically, bottom line, it's not feasible in reality. And costs become super high because you have to, at the end of the day, then create a new account every single time, use a different credit card, and even maybe, I don't know how, but they may even require you send or you put a different address, or like a box, like the Dropbox in town that some friends of mine also do. So all I'm saying is that the cost of privacy increases with the purchases. It goes up. I just wanted to mention that, which may not be suitable at all or interesting for your model because your model is a sterilized model, as you indicated, but these are some thoughts of mine. And thank you again for taking the time, for coming today, for presenting your work, which is very interesting.